tens, Ellipsis here. Today we're going to learn about how to solve equations with variables on both sides. Before, we solved equations with one step and multiple steps, but our variables were always on one side of the equation. So now we're going to solve an equation when the same variable is on both sides. Some terms to know. Like terms are terms that can be combined using addition and subtraction. An example is 2x and x, because they both have the same variable. I'll elaborate on this later. Unlike terms are terms that cannot be combined using addition and subtraction. An example is 2x and 3y. Again, I'll elaborate on this later. Let's take this equation. 4 plus 5 is equal to 17 minus 8. If we solve this, 4 plus 5 is equal to 9, and 17 minus 8 is equal to 9. So 9 is equal to 9, and this equation is true. Now, if we have this equation where I've replaced the 4 with x and 8 with 2x, you can see that x is equal to 4 because all I've done is replace this. And if you want to check with this, 2 times 4 does equal 8, so that's true as well. So x should be equal to 4, and you're correct. But we have a variable on two sides, so how are we going to solve this? Let's move on to the next slide. So, how do we solve for x? We get our variables on one side and our constants on the other. And how are we going to do this? We need to add and subtract like terms as we need to, and we need to use the inverse operations and or the reverse order of operations as well. Now, you must be wondering, what is a like term and what is an unlike term? Because I haven't explained that yet. Well, a like term is any term that has the same variable. So, if we have this 2x plus 5x, you can see that I have put the x's in green and the rest of the equation in white. And if you're wondering why I put these x's in green, it's to signal to you that these two are like terms and can be combined using addition or subtraction. How? Because both of these terms have this x at the end. If it were a constant and a constant, if I were just adding 2 plus 5, I could do this and end up with 7. And now that we have this x, if I add this x to this equation, 2x plus 5x, then we would end up with 7x because these two can be combined. Let's show you an example of what unlike terms look like. Suppose we have this expression, 7x minus 2y. Notice that I have put the x in green and the y in red. This signals to you that these two are so different that you cannot combine them using addition and subtraction. So this remains 7x minus 2y because we can't solve for that. And x and y are two different variables. Alright, let's show you another example. 3x minus 2y plus 4x y. Now, you may be thinking that there's an x here. We can combine it with x. But there's also the y there. So you can theoretically combine it with y, right? Wrong. You cannot combine any of these because none of them are like terms. Why? Because this one only has an x, this one only has a y, and this one has both. So you have to have the exact same variable or variables after your constant so that these terms can be like. So this 2 remains 3x minus 2y plus 4xy. Alright, let's try some examples. Let's take this first one. 3x minus 4 is equal to 4x minus 8. Now notice that we have the same variable here, x. And that's the only variable we have. So these two are like terms. And all constants are like terms no matter what. So these two are like terms as well. What we want to do is bring the constants on one side and bring the variables on one side. So what we would do is we could add this 8 to both sides to get rid of it. And again, since this is a multi-step equation, we need to follow the reverse order of operations and do the inverse operations in that order. And so we can add 8 to both sides, and we end up with 3x plus 4 is equal to 4x. You may be thinking that, yes, now we have this variable on this side and now we can solve it like it's a normal single-step equation. Wrong. You still have this variable here. So we need to get rid of this from this side and move it here. And what we would do is we would subtract 3x from this side. Now, if you're thinking that, oh, but there's a 3 there, we can divide by 3. We need to do that because that's reverse order of operations. It's not reverse order of operations here. We need to subtract this whole term. We don't need to divide this whole side by 3 because that would just mess things up even more. So we need to subtract 3x, the whole thing, from this side. And we're doing this because we're not trying to isolate x here. We're trying to move these to this side so that we can isolate x. And that may sound a little confusing, but we'll see. So we subtract 3x from here and 3x from here. And notice how these things perfectly line up to give us x on this side, because 4 minus 3 is equal to 1, and there's an invisible 1 here. This means the same thing as 1x. And so this 4 remains, and we are left with x equals 4. So let's check that. Let's plug in 4 for x. So 4 times 3 minus 4 is equal to 4 times 4 minus 8. So we need to use the order of operations here, and so let's do this side first. 12 minus 4, and now let's do this side. 4 times 4 is 16, so 16 minus 8, and now let's evaluate each side. 12 minus 4 is equal to 8, 16 minus 8 is equal to 8, so 8 is equal to 8, and we're good. Let's try the second one. And before I show you the steps, I encourage you to pause this video and try this out on your own, following the steps shown here. Alright, I'm assuming that you're done and you've got an answer, and now you're waiting for me to check with you. So let's do this. Negative 7x plus 2 is equal to 5x plus 6. So you can do this either way, but I prefer to move the constants first and then move the variables and keep everything as positive as I can. So keep as little negatives as possible. So I would prefer to move 2 to this side, but then I would have to move 5 to this side, and that just gives me a bigger negative. So I will move the 6 from here to here, and I'm going to do that by subtracting 6 from both sides. And this gives me negative 7x minus 4 is equal to 5x. Again, we're not done yet. We need to move this to this side and the whole thing to this side. So we need to add 7x to both sides. And this gives us negative 4 is equal to 12x. I prefer to keep the variable coefficient positive, and in another video I'll tell you what a coefficient is and all that vocabulary. So we are left with negative 4 is equal to 12x. And so we need to divide this by 12 because we're now at that single step equation thing. So let's divide both sides by 12. And we are left with negative 4/12 is equal to x. And we can simplify this, so let's do that. And we notice that 4 goes into 12, so we divide this by 4. 4 divided by 4 gives us 1, and 12 divided by 4 gives us 3. So this is equal to negative 1/3. And a lot of people get tripped up because there's this negative here and they don't put that, but there's still the negative, so we need to keep track of that. So let's check now. Okay, so now to evaluate these. Negative 7 times negative 1/3 is equal to 7/3. So I prefer to keep this an improper fraction because it's easier for me. Plus 2 is equal to 5 times negative 1/3 is equal to negative 5/3 plus 6. Now, to evaluate this, it would be much easier if we made these into fractions as well, improper fractions. So let's do that. 7/3 plus 2 times 3 is equal to 6, so 6 divided by 3 is equal to negative 5/3 plus 6 times 3 is equal to 18, so that's 18/3. Now if we want to evaluate this, 7/3 plus 6/3 is equal to 13/3, and negative 5/3 plus 18/3 is equal to 13/3. So 13/3 is equal to 13/3, and we're done. Thanks for watching. If you liked this video or this helped you, click that like button. If this didn't help you, click that dislike button. I greatly appreciate feedback. If you want more updates on new videos, click that subscribe button and turn on notifications. If you have any questions related to this topic, put those in the comments below. And remember, the comment section is the equivalent of a classroom discussion, so if you have any answers to any of the questions, you can answer those. If you have any suggestions on how I can improve my future videos, or even what I should do next, put those in the comments below as well. If I like your suggestion, I'll be sure to include that in the next video and give you a shout out. See you in the next one.